Okay, so now we move to the environmental analysis, right? So as you can see here, this section actually shows a kind of a critical question for study area, right? I mean, how hot and kind of uncomfortable is the outdoor environment for pedestrian, right? People walking along the corridor. So unlike the overview live weather panel, actually this tab uses kind of a modeled environmental data, actually not real-time API weather, right? So these are pre-processed GeoJSON files. We used UMEP analysis and all the UMEP analysis, and then this analyzes basically thermal comfort, cell as UHI, even heat island. You can see here, see UHI and shadow analysis, also sky openness across a 10-meter grid inside. Then this is boundaries 800-meter buffer, I mean boundary. So first one, left panel min max, you can see the UTCI values. Actually, UTCI tells us how hot the environment feels to the human body, right? Not just air temperature. It combines actually air temperature, humidity, and wind, and different. I mean, other things, radiation, right? So the minimum and maximum values are here. So actually, this large range shows kind of a strong spatial variation, right? So some streets are actually much harsher than others. So if we toggle on the UTCI map, you can see, right? So yeah, along the Gold Road corridor, you can see the highest color ramp. Actually, if we neglect the seas, because you can see all these blue color areas are the lowest, and most of the time it is due to the shade as well as the canopy cover, and yeah, that's the main thing, right? So uh, then UTCI comfort gauge, right? And this actually tells us how hot the environment feels to the human body. Again, I mean. Overall, right? Overall, how thermally stressful the corridor for pedestrians, right? So this is the range is cooler and the hotter, and this is the range. So this supports, you know, we can get plan decisions like shade and cool surfaces as well as pedestrian friendly street redesign, right? So here you can see the coolest and the hottest cell IDs, uh, and then heat spread classes. Actually, this shows how many grid cells fall into model heat stress classes, right? You can see strong heat stress between 32 and 38, and very strong 38 to 46, right? So this is actually categorized, and the shadow exposure, if we can toggle on the shadow, and you can see here again, right? So shadow exposure means actually the share of model daylight hours when cell is in shadow, right? So actually we took a model period as 2026 July 5, between from morning 7 a.m. to 6 p.m., right? So these are the categorization we did. So actually this tells us most of the grid spends large part of daytime in shade, right? So as well as, but a significant share remains highly kind of sunlit areas, mainly the Gold Road corridor, as well as other major artery, sub roads related spaces, right? So again, you can see all the map layers are in the fab menu. So right panel, if we talk about this right panel, it is the UHI intensity, right? Actually, UHI measures how warmer, how much warmer each urban cell is compared with the kind of a rural, yeah, with the rural background. So rural background temperature is related to in this diagram actually. It is rural temperature is 26.59. Yeah, I guess. So study area, you can see the mean values and all that. So this actually basically the meaning of UHI is actually, uh, is this our urban area, our study area uniformly hotter than the rural surroundings? That's what measures through the UHI, right? So mean UHI, if you see this, mean UHI is close to kind of a neutral, but local hotspots, right? So local hotspots you can see exist, you know highest one. If we remove the C area, you can see again the Galle Road corridor and the other building density areas, right? So heat stress actually is driven more by kind of based on the local geometry as well as the radiation than one uniform urban warming value, right? So there are multiple values related to this UHI. So UTCI and UTCI was UHI intensity. Here actually this shows do the hottest feeling places always match the highest UHI. It's one of the most kind of critical, findings. I mean, for a critical finding, we can use this graph, right? Hottest failing places always match with highest UHI, right? So actually not always. As you can see here, many high UTCI cells can occur due to the radiant heating, right? That canyon effect and low ventilation, even when UHI is in a moderate value. So this helps actually explain why shade as well as the street geometry matters. As much as general urban warming, right? So shadow throughout the day you can see here. So shadow rises through the late morning and peaks around between 12 and 2 p.m. And then falls toward the evening, right? So this actually shows, when is the corridor, our urban area, most shaded during the day, right? So midday has the highest shadow coverage, and but sunlight exposure actually still remains in significant in many cells, right? So we analyzed that before. Yeah, that's it. Uh, so again, midday has the electricity for higher shadow coverage. So for pedestrian planning, actually, we can implement some kind of strategies by analyzing this shadow exposure, right? So morning and late afternoon, as you can see, morning period and late hours afternoon can still be, kind of bring a harsh, kind of a very, uh, uncomfortable where shadow is lower, right? So that thing, actually, that factor, that what we found, we have to implement some kind of strategies when it comes to urban design, urban planning, right? So if you want to give a kind of a comfortable environment to the pedestrian, definitely we have to analyze this shadow exposure, right? So then the other one is actually the microclimate signature, right? This is kind of all in one. This is called as a spider graph, right? Some say radar chart also. So this chart actually compares relative strength of each key drivers, right? UTCI, UHI, air temperature, likewise. So this is basically about what combination of factors helps to define all our study areas microclimate, right? So in this corridor you can see the UTCI and radiant temperature, right? And influences are so strong here, right? See, and the wind contribution is kind of a limited, relatively limited in the normalized profile. It is due to actually the high dense of buildings are here because the sea breeze are coming from this side. But when it comes to Galle Road near area, we couldn't identify. We couldn't feel some kind of that windy nature, right? But when it comes to this Dehiwala area, it has some kind of open space for. Not everywhere in the Dehiwala. Most of the time. After see the ground St. Thomas College and this area, we could feel that sea breeze for like more than the Hivala, sorry, Mount Lavinia area, right? So and then sky view opens actually. If we toggle on the SGF sample points, here you can see we took actually from the Mount Lavinia junction along the Galle Road and the Mount Lavinia market area, as well as another building, high-rise building, and the bus stand and the post office area, right? So here uh, we can identify this walking pathway is kind of an open one or some kind of a canyon likewise, right? Actually, along the Galle Road, we could see, very open, right? From the Galle Road, actually Mount Lavinia junction to this side. But here the red dots are actually related to due to the shade generated by the market building here, circular road, as well as here a big canopy cover is there, a huge tree near the post office, as well as this is another building, it's a high-rise apartment. So shade is generated by these buildings, right? So the openness is very low, and these green ones are actually inside the market building, so there's no roof in the Molania market building, so it's kind of a get a moderate one, right? So in planning terms, right? So we could see by analyzing all of these things, Mount Line actually needs kind of a we should prioritize the shade, right? As well as the pedestrian cooling. Also, street canyon, I mean the canyon effect mitigation along high UTCI segments, right? It means again the road corridor, right? Especially um also around the junctions as well as mainly the Galle Road corridor related to the urban core, right? So that's it for the environmental analysis, right?